Okay, so today we're going to talk about section 1.5, which is on linear equations, functions, zeros, and applications. So we're going to be ending up with a few word problems at the end of this section. First of all, we need to review some definitions and terminology that we covered in R5. So this should be a review if you've seen exactly the same stuff in R5. So first off, what is an equation? So an equation is just a statement where two expressions are equal to each other. So one thing to look for in an equation versus an expression is the equal sign. So when you see an equal sign of two expressions, it's an equation. So the next part is, how do we solve, or what does it mean to solve, right? So to solve an equation is to find all the values to make the equation true. And we'll do a few examples in a minute. And so the values that make the equation true, we call it the solution. And the set of all the solutions to make the equation true is called the solution set. So sometimes we're going to see that it has maybe one, two, or a few solutions, but other times it's going to have infinitely many, other times it's not going to have any. So we'll take a look at some examples where each of these cases happen. For now, we're going to restrict ourselves to linear equations. So as we progress in the semester, we'll look at different types of equations and whatnot, but for now, linear. So what does it mean to be linear? It means that it's at least in one variable linear equations, we're going to be looking at things that can be expressed in the form mx plus b equals 0. So the key word here is that it can be expressed. So by manipulating the equation, that you can put it into the form mx plus b equals 0, where m and b are real numbers and m is not 0. So once again, a review from R5 is what we call equivalent equations. So equivalent, or equations are equivalent as long as they have the same solution set. So that's all that means to be equivalent. So they may not look the same, but when you solve it, their solutions are exactly the same. So there's three types that we can have when we're talking about linear equations. So the first one is an identity. So basically for this one, when you solve the equation, it's just saying that you can plug in any real number and the entire statement will be true. So a case like this would come about when you're trying to solve it using algebraic manipulation, and at the end you get a true statement. So all the variables go away and you get something like 0 equals 0 or -1 equals -1. Something that leads to a true statement will be an identity, meaning you can plug in any values of x in real numbers and the statement or the equation will hold true. And the second case is called a conditional equation. So that means you can plug in some numbers to make the equations true, but there are other numbers where the equation does not hold. So that's why it's called conditional, meaning under certain conditions, meaning for some variables or for some numbers that you plug into the variable it works, but otherwise it doesn't. The last one of those is going to be a contradiction, meaning it has no solutions whatsoever. So the way you would recognize this one is when you solve for x and you try to isolate x, so you're in the process of solving, the variables will go away and you'll get something like -3 equals 7, which is a false statement. So whenever you're solving an equation and you get a false statement, that means that it has no solution sets, meaning there's nothing that you can plug into the variable to make the equation true. Okay, so in the next video, we're going to do some examples of such.